Welcome in everybody to another lesson. Today we are going to talk about decimals and variables. So I have 4 example problems here, and a lot of you are probably familiar with variables already now that we've been doing them with whole numbers and fractions. So we have our first one here, x plus 17.5 is equal to 29.15. Well, the goal to solving any variable equation, of course, get the variable by itself on one side of the equation. So in order to do that, we're going to have to subtract 17.5 from the side with the x, but what you do to one side, you got to do to the other. So it's going to be x plus 17.5 minus 17.5 is equal to 29.15 minus 17.5. Okay? Well, we now have 17.5 minus 17.5. That'll go to 0. X will end up being by itself. We'll have x equal to 29.15 minus 17.5. Okay, that's fine. All we need to do now is solve a simple subtraction equation, which we will work out on the side. So we will have 29.15 minus 17.5. Okay? Well, one term of the equation has 2 decimal places. The second term only has 1 decimal place. So in order to make sure both have 2 terms, we need to make the second term have 2 terms. We just tack on a 0 at the end. And that's how you make sure the second term also has 2 decimal places. We may now do the subtraction. 5 minus 0, that's just 5. 1 minus 5 doesn't work. That's got to become 11, which means we got to borrow 1 from the 9, turning that into an 8. 11 minus 5, that's 6. 8 minus 7, that's 1. 2 minus 1, well, that's going to be 1. Now, since both terms of the equations had 2 decimal places, that means your answer has to have 2 decimal places, which would be 11.65. Which would have to mean that x is going to equal 11.65. And that is your solution to this equation. X equals 11.65. And not much to it. I got 3 more examples. Alright. How about we have t plus 50.7 is equal to 54.07. Okay, again, like any variable equation, the goal is to get the variable by itself. How are we going to do that? We're going to subtract 50.7 from both sides. So you'll have t plus 50.7 minus 50.7 is going to end up equaling 54.07 minus 50.7. Okay? Well, now we have 50.7 minus 50.7. Good news is that'll go to 0. We'll end up having t by itself. That's going to be equal to 54.07 minus 50.7. Now we are just left with a subtraction problem that we got to solve. I will work that out over on the side here. So we have 54.07 minus 50.7. Okay. First term of the equation here, it has 2 decimal places. The second term has 1 decimal place. Well, in order to perform the subtraction, we have to make sure both of the terms have two decimal places. All we got to do is just tack on a 0 at the end. And now they both have two decimal places. So now we can do the subtraction. 7 minus 0, that's 7. 0 minus 7 doesn't work. We got to make that 0 into a 10, which means we got to borrow 1 from the 4, turn that into a 3. Now 10 minus 7, that's 3. 3 minus 0, that's 3. 5 minus 5 is 0, which we really don't need to write. So since both terms of the equation had two decimal places, your answer must also, which would end up being 3.37. So your answer to this is going to be t is equal to 3.37. And that would be all there is to it. T equals 3.37. Alright. Not too bad so far, right? How about we do this one? We've got two more examples here. I have 3.205 rather plus m is going to be equal to 22.456. Well, if it helps you, you don't have to, but if it helps you, what you can do is use the commutative property on the left-hand side and switch the m and the 3.205 around. So you'll end up with m plus 3.205 equals 22.456. Okay. Now, of course, like before, we want to get the m by itself. We want to get that variable by itself. So we will do m plus 3.205 minus 3.205. But what you do to one side, you got to do to the other. That's going to be equal to 24.456 minus 3.205. Okay? Well, 3.205 minus 3.205, that's 0. You'll get m by itself. Now m is equal to 22.456 minus 3.205. We are left with a subtraction problem now that we can work out on the other side of the board here. So let's go ahead and do that. You'll have 22.456 minus 3.205. Well, good news with this equation, both terms of the equation have three decimal places, so we could straight away go ahead and do the subtraction. 6 minus 5, that's 1. 5 minus 0, that's going to be 5. 4 minus 2, that's going to be 2. 2 minus 3 doesn't work. We got to turn that into a 12, which means we got to borrow 1 from the 2 that's next to it, turn that into a 1. 12 minus 3, that's 9. 1 minus 0, that's 1. So now, since both terms of your equation had three decimal places, your answer must also, which would give you 19.251. So your answer for what m equals, m is going to be equal to 19.251. And you can always check your work by sticking the value you got for the variable into the original equation, and it should equal. The left-hand side should equal the right-hand side. We're skipping that step because for time, and plus I've demonstrated before how to stick it back into the equation, but you can or can't, I mean, it's up to you. But m equals 19.251. Okay? Then I got one more. Just one more here. Okay. We have 17.95 plus p is equal to 402.5. 0.63. Well, if it helps you, again, use the commutative property, switch the p and 17.95 around. So you'd have p plus 17.95 is equal to 402.63. Okay, of course, like any variable equation, you want to get the p by itself, get the variable by itself. So you'll end up having p plus 17.95 minus 17.95 is equal to 402.63 minus 17.95. Because what you do to one side, you have to do to the other. Okay, so 17.95 minus 17.95, that's 0. Which means you got p by itself is now equal to 402.63 minus 17.95. Now we're reduced down to a subtraction problem. Then we'll have the answer to p, which we will work out on the side. So we have 402.63 minus 17.95. Well, good news is both of the terms of the equation have 2 decimal places, so we can go through and do the subtraction. 3 minus 5 doesn't work. We got to make that a 13. We borrow 1 from the 6, that turns into a 5. So 13 minus 5, that's 8. 5 minus 9 doesn't work. We got to turn that into a 15. Which means we got to borrow 1 from the 2, turn that into a 1. So 15 minus 9, that's 6. 1 minus 7 doesn't work. We got to turn that into 11, which means we got to borrow 1 from the 0, which means that would have already had to have been a 10. So that becomes a 9, which means we got to borrow 1 from the 4, turning that into a 3. So 11 minus 7, that's 4. 9 minus 1 is 8. 3 minus 0 is 3. Okay, so since both terms of the equation had 2 decimal places, your answer must have 2 decimal places, which would be 384.68. So the answer to this is p equals 384.68. And that would be all there is to that. So variables, again, whether you're working with whole numbers, fractions, decimals, always get the variable by itself. And then you work through whatever operation you have on the right-hand side of it. So I could tell you next lesson we are going to move into multiplication of decimal numbers. It is radically different from doing addition and subtraction of them. When we get to the lesson, you'll see why. But stay tuned for that. I hope everybody has a good night. Thank you.